So you know that thermodynamics is an experimental science. So this science is based on certain principles, or these principles are generalizations made from experiments, like through experience. And thermodynamics mainly it focuses on the transformation of heat into mechanical work. So input is heat or energy in the form of heat, and whatever output we are getting it will be a mechanical work. Okay, so it's an old science and started uh, in the early 19th centuries, and that time thermodynamics was mainly doing how to improve the efficiencies of steam engines. Steam engine. We know that for a steam engine, input is heat and output is a mechanical work. So the principles of thermodynamics, you know that it helps engineers to design and build internal combustion engine. We will discuss some of these engines in this topic in this paper, and also the designing of nuclear power stations, refrigerators, day-to-day application, day-to-day life application, air conditioning systems, അതുപോലെ തന്നെ propulsion systems for rockets, missile, aircraft, etc. So in all these areas, the principles of thermodynamics is extensively used. Okay. So today what I'm going to do is to revise some of the concepts that you require for learning thermodynamics. Okay. So we will discuss thermodynamic systems, then thermodynamic variables, then thermodynamic equilibrium, zeroth law of thermodynamics, and first law of thermodynamics. Okay. So what is a thermodynamic system? What do you mean by a thermodynamic system? How do you define a thermodynamic system? You know that system is the part of the universe under study within some closed surface. And we call this closed surface as boundary. So there is a system and a boundary and things outside the system. So system is the area or the part of the universe where we are looking for and we are doing something. And there is it will be surrounded by a closed surface. We call it a boundary. Maybe a physical surface or some imaginary surface. And we call it boundary. And which separates the system from surrounding. And what is surrounding? Anything outside the system and which can exchange energy with the given system. That is called surroundings. So you can see here system and which is separated by a boundary. It can be physically present or maybe an imaginary thing and surroundings. Okay. Now, how many systems? What are the kinds of systems? So you can see this picture. So first picture you are seeing a cup of tea, open cup of tea. Okay, or open glass with some liquid or solution. And below that you are seeing one thermo flask. Then you are seeing two beakers. You are heating those beakers and one is closed with a lid, and another there is no lid, and you have another closed by a adiabatic wall. Okay, so can you tell me? Can you differentiate the systems? What are these? Are examples of systems, different kinds of systems. So what about the first one? A cup of tea flowing, the thermal flask will not allow heat to flow outside the system. That's why it's called thermal flask. Heat or energy, heat is a form of energy which is not flowing outside from that system. So that is one kind of system, and another system which is closed. We can the first one is open system where you a cup of tea and there is no lid, it is open. So it's an open system. So open system means the system can exchange matter and energy with the surrounding. That is called open system. And what about closed system? You can see here. You can see one uh, flask which is closed with a lid. So that means no matter is flowing outside the system, but heat can flow. Energy can be interchanged with the surrounding. So such systems which can exchange only energy and not matter with surroundings are called closed systems. And come back to this thermal flask. Thermal flask is not allowing any matter to go outside that flask or outside that system. And at the same time, it's also not allowing any heat energy to go outside or come inside the system. So it's called an isolated system. So an isolated system is a thermally insulated system in which no matter and energy in the form of heat is transferred to the surroundings or from the surroundings. Not going to the surroundings and no heat is coming into the system from the surroundings. Okay, I think now you can differentiate between various systems. Okay, so now let us tell you something about thermodynamic variables. So we will discuss what are thermodynamics variables. What are thermodynamic variables for? So they are some observable properties of the system. That properties that you can measure. They are the observable properties of the system. So there are four properties: pressure, and pressure we will represent it by let symbol capital P. Volume, we will represent the volume now onwards by capital V. Temperature by capital T, and composition. Composition is a type kind of material or matter you are selecting. Now, what is equation of state? Equation of state is the function of these thermodynamics coordinates or variables. F, if we take the function as a F, it's function of P, V, and T. Okay. So now tell me your concept or your idea about thermodynamic equilibrium. So when will you say that our system is in thermodynamic equilibrium? So if a homogeneous system in which any two of the three thermodynamics variables P, V, or T remains constant as long as the external conditions remain unchanged. And such a system should satisfy mechanical equilibrium, thermal equilibrium, and chemical. What do you mean by a homogeneous system? So, homogeneous system means a system which is completely uniform. That system is completely uniform throughout. So if you take a gas or a mixture of gases, when you move from one point to another, the properties of the system, the density, whatever the properties of the system will be remaining uniform throughout the matter. Whether it is a gas or a mixture of gases, pure solid or solutions, liquid, homogeneous system means it should be completely uniform throughout properties of the system. Now, another system is called heterogeneous system. What do you mean by heterogeneous system? Heterogeneous system means a system which contains two or more phases separated one another by some definite boundary. So we are talking about homogeneous system, a homogeneous system in which any two of the three variables P, V, or T remains constant as long as the external condition remains unchanged. And such a system should satisfy mechanical equilibrium. What do you mean by mechanical equilibrium? Mechanical equilibrium എന്ന് പറഞ്ഞാൽ no macroscopic movement within the system with respect to the surrounding. Means there are no unbalanced forces, mechanical forces exist in the system with respect to the surroundings. And what about a thermal equilibrium? എന്താണ് thermal equilibrium? Thermal equilibrium എന്ന് പറഞ്ഞാൽ no temperature difference between the different parts of the system or the system and between the surroundings. There's no temperature difference. Such systems are called systems in thermal equilibrium. And what about chemical equilibrium? Chemical equilibrium എന്ന് പറഞ്ഞാൽ there are no chemical reactions within the system and no movement of any chemical constituent from one part of the system to the other, and such systems are in chemical equilibrium. When a homogeneous system satisfies all these equilibria, mechanical equilibrium, thermal equilibrium, and chemical equilibrium, we call our system is in thermodynamic equilibrium. Okay. So I will show you one example of this thermal equilibrium. Okay. So let's say that we take നമ്മളൊരു example ആയിട്ട് എടുക്കുക. We take two materials of same volume, same type, same kind, same materials. And let's say that initially these two blocks, let's say that there are two blocks of some solid or some metals, same metals. A and B are same metals, but that temperature is different. Now, what we do is we make a contact between A and B, two blocks of metal with same material but with different temperature. We allow them to come together. We make a contact between A and B and close the system by a adiabatic wall. Adiabatic wall എന്ന് പറഞ്ഞാൽ that wall does not allow heat to flow from the system to the surroundings or from surroundings to the system. So what will you observe after a long time in contact? You allow them to be in contact with each other for a long period of time. And what will you, if you touch A and if you touch B and you touch B, you will feel the, okay. So you allow A and B to be in contact with each other for a sufficiently long period of time. And after some time, when you touch either A or B, you feel both of them are equally warm. We can, this is one case. Okay. Now you take different materials. Maybe one is a metallic block, another maybe a wooden material. They are of different temperature, and you allow them. You make a contact between them. You allow them to come together, keep them together, make a contact between two blocks, and you seal this chamber with some adiabatic boundary, and you allow the system to be in contact with each other for a sufficiently long period of time. And when you come back after some time and touch block A and block B, they are of different materials. What do you feel? You may not feel them equally warm. Like, so one will be a different temperature, another will be a different temperature. So these are the two cases. Why they are not equally warm? Because there are two materials, two different materials, and two different materials have different thermal capacities. Like, their specific heat will be different. So, what is your observation? Now, if you think about both these cases, whether the materials are same or the materials are different. So the end state, when you observe them for a sufficiently long period of time, we reach a state in which there are no further observable changes in the measurable properties of the system. പിന്നീട് ആ സിസ്റ്റത്തിന് കുറെ അങ്ങോട്ട് പിന്നെ മാറ്റങ്ങളൊന്നുമില്ല, ടെമ്പറേച്ചർ മാറ്റവും ടെമ്പറേച്ചർ ഡിഫറെന്റ് ആയാലും സെയിം ആയാലും ആ ടെമ്പറേച്ചേഴ്സ് that will not change further. That came to an end state. പരസ്പരം heat exchange ഒക്കെ നടന്നു, and a final state is reached, and from that state onwards there are no further changes in the system. So we can say that system is reached into a thermal equilibrium. Both systems reached in a thermal equilibrium. Okay. So all ordinary objects, they have a physical property, they have some physical property that decides whether or not the systems are in thermal equilibrium or not when placed in contact with each other. ആ പ്രോപ്പർട്ടിന്റെ പേരെന്താ? The property which decides whether they are in thermal equilibrium with each other or not. ആ പ്രോപ്പർട്ടിയുടെ പേരാണ് temperature. So something that differ these things from one another. എന്താണോ ആ physical propertyയുടെ പേരാണ് temperature. Okay. Temperature is the measure of heat energy. So we define this is a definition of zeroth law of thermodynamics. So let us take two objects A and B, two bodies A and B. Let's say that we take two system A and B, and A and so let's say that A is the first system. So A is in thermal equilibrium with the third system. So A and C are in thermal equilibrium. B and C are also in thermal equilibrium. But A and B are separated by a adiabatic wall that is connected by a wall which does not allow heat or matter to flow from one another. A and B are separated by some boundary. But A and C and B and C are in contact. And after some time, A and C, B and C will reach into thermal equilibrium. നമ്മൾ നേരത്തെ കണ്ടതുപോലെ A and C. Let's say that A, B, and C are three different blocks of materials with different heat energy, maybe same material, right? With different. So we keep them. We make a contact between A and C. We make a contact between B and C. Then after some time, we can say that after a sufficiently long period of time, we can say that A and C, B and C are in thermal equilibrium. Then the zeroth law says that if A and B are in separately thermal equilibrium with the third system C, then A and B are also in thermal equilibrium with each other. Okay. Let's say that there are three blocks of materials A, B, and C. They may be with different temperatures, but you make a contact between A and C. So what we do is we make a contact between A and B. A and B will not. A and B in the contact illa. That is separated by an adiabatic wall or an insulating wall. But we make a contact between A and C and B and C, and we keep them in an adiabatic wall so that no energy is exchanged. Okay. So when you keep this system for some long period of time, what happens is A and C will be in thermal equilibrium, B and C will be in thermal equilibrium. Then zeroth law of thermodynamics says that A and B will also in thermal equilibrium with each other. Okay, this is the zeroth law of thermodynamics. And this law gives you the concept of heat. So all the objects have a physical property. A physical property, I am underlining physical property, that determine or decides whether or not these objects are in thermal equilibrium when they are placed in contact with each other. Our property endano adana in the temperature. So this concept of temperature or the concept of heat is coming from zeroth law of thermodynamics. Okay. Now we talk about internal energy. So what is internal energy? Tell me what is internal energy. Internal energy എന്ന് പറഞ്ഞാൽ എന്താണ്? So internal energy is the total energy content of the system. ഒരു സിസ്റ്റത്തിന്റെ മൊത്തം എനർജി അത് പൊസസ് ചെയ്യുന്ന the energy that possessed by the system is called internal energy. And this internal energy can come from different energies of the system. കഴിഞ്ഞ ക്ലാസ്സിൽ total energy possessed by the system. So this energy can come from kinetic energy, So kinetic energy is coming from, if you are talking about a molecule, the kinetic energy can come from the translation motion of the molecule, translational motion, rotational motion of the molecule, vibrational motion of the molecule, So kinetic energy can be coming from rotation, translation, rotation, vibration, energy of the molecule. And potential energy, potential energy. So potential energy can be the intermolecular forces. It is due to the intermolecular forces, and this depends on the separation between the molecules. Okay, two molecules, will say A and B. The potential energy depends on this separation R between them. So the energy, the total energy content of the system can come from the easily will come from the kinetic energy. Kinetic energy means that is the total. The energy is composed of translation energy and down, rotation energy and down, vibration energy of the molecule, and plus potential energy. And if you talk about an atom, so there is a nucleus, there is an electron. So this energy can also come from the energy of the electrons and energy of the nucleus. So that means this is the total energy content of the system is called internal energy. So whatever the total energy possessed by the system is called internal energy. Okay. And if you supply some energy to a system, let's say that you are supplying some energy to a system, a beaker with a piston, a beaker containing some gas, some mixture of gas. But നമുക്കറിയാം this gas system or the gas mixture contained in this system, closed system, this system, that will these molecules of the system will make translational movement, rotational motion, vibrational motion. They, due to their interatomic separation, there will be potential energy. So there are many contributions from various factors. So the total energy contained in the system is called internal energy. Now, what will be happening when you are applying some amount of energy in the form of heat to the system? നമ്മൾ ആ ഒരു ബീക്കറിൽ ഒരു ഗ്യാസ് ഉണ്ടെങ്കിൽ if we are heating the system, then what will happen? എന്താ സംഭവിക്കുക? There is a movable piston attached to the system and you are heating the system. എന്താ സംഭവിക്കുക? The piston will move up because the gas will expand due to the expansion of gas in the volume in the chamber, in the beaker. The movable piston that will go up, that will move. So the work is done by the system here. System is doing the work. So you are not applying this. If you are applying a system force, you will compress the gas. So here the work is supplied, work is done by the system. So you are applying a heat energy and some amount of work is done by the system. Okay. Now we know that the energy is conserved. Like energy is a conserved quantity. So if you apply some energy in some form, that can do work in some form, some other form. But the total energy of the system will be conserved. So that is the concept of conservation of energy. So when you apply a small amount of work, delta Q, with some small amount of you are supplying a small amount of heat energy, let's say delta Q, so that the system is doing some work, delta W. Then, so what happens to the state of the system? So initial state, and the system goes from some initial state to final state. System is in some initial state and it goes to some final state. Okay. So what is happening here? Let's say that നമ്മൾ പറയുന്നു initially the internal energy of the system was U1. Now you are supplying some heat energy, and the system is reaching to a state in which it is having the internal energy will now be U2. The system reaches a state 2. So the total energy in the form of heat supplied to the system is utilized for two purposes: to do work which is done by the system, and the internal energy is changed from U1 to U2. Internal energy is changed from U1 to U2. So the total energy is now conserved. You are supplying some heat energy, the system is having some internal energy, and this internal energy is when you supply some energy is utilized for increasing the internal energy or changing the internal energy, and some part of the work is used to do work. And this is called the differential law of first law of thermodynamics, differential form of first law of thermodynamics. Differential form of first law of thermodynamics. So the first law of thermodynamics states that. So what is your understanding of the first law of thermodynamics? When there is a when you supply some energy to the system in the form of heat or delta Q, a very small change in the state of the system happens, and this change in internal energy, and some work is done by is done. So this is the first law of thermodynamics. So the concept of internal energy is coming from the first law of thermodynamics. So initially we have some internal energy, and internal energy changes when some heat is applied to the system. Okay. So the zeroth law of thermodynamics will give you the concept of heat, and the first law of thermodynamics will give you the concept of internal energy. Okay. So please go through these topics so that we can continue our discussions.